We are going to start now the lecture 7 of chapter 2, class 11 mathematics, relations and functions. So in this chapter we will discuss some problem based upon domain and ranges of real functions. So the first function that is given to us, it is fx is equal to 1 over x plus 3. So first of all we are calculating the domain of this function. So domain of this function means we want to calculate all those values of x for which this function can be defined. Defined means that all the values of fx should exist. Now suppose I am substituting the value of x is equal to 3. So the value of f of 3 we will have it is 1 over 3 plus 3, and this is a real number. So we are saying this function is defined for 3. If suppose I am substituting x is equal to minus 7, I will get f of minus 7 is equal to 1 over minus 7 plus 3. Again this is some real number, it means function is defined over here. Now suppose I am substituting x is equal to minus 3. I am substituting the value x is equal to minus 3. So what will happen over here? We will get f of minus 3 is equal to 1 over minus 3 plus 3, and this term we are saying the denominator over here, this will be equal to 0, and this term is not defined. We are saying 1 by 0 we are considering it is not defined. We are not writing it is infinity, we are saying this term is not defined. So it means for x is equal to minus 3, this function is not defined. So this function, when we are talking about, this is a rational function, and we know that the rational functions, they are not defined at the points where the denominator is equal to 0. It means it is not defined at the point that x should not be equal to minus 3. So the domain of this function f, that is equal to all real numbers except this number minus 3. This is the domain of this function. Next we have to calculate is the range of this function. So to calculate the range, we are equating this value is equal to y. We are adding y is equal to 1 over x plus 3. So, and we calculate the value of x from this. So we are writing it is 1 over y is equal to x plus 3. And this thing implies us that x is equal to 1 over y minus 3. So we are saying, suppose there is another function. We are talking about one function that is given to us is y is equal to fx is equal to 1 over x plus 3. We are talking about another function over here. Suppose that function, we are saying it is x is equal to some function g of y that is equal to 1 by y minus 3. This is another function. So what we will study further, that both these functions, these are inverse of each other. The first function is inverse of second, and second is inverse of first. And from the properties of the inverse of functions, we know that the domain of this function will be the range of this first function. This thing we have studied in the properties of the inverse of the the domain and range of the inverse functions. We have seen over there that the domain of the function, that will be equal to the range of the inverse function, and range of the function, that will be equal to the domain of the inverse function. To verify these are the inverse function, this is not the part of your class 11th, it is part of your class 12th, and we will study in our next lectures. But right now you can consider that these two functions, these are inverse of each other. So to find the range of this first function, we are calculating the range, the domain of this second function, and this function is not defined when y is not equal to 0. We are saying this function is defined for all real number except for the number 0. It means the range of this, the domain of this function, we are saying the domain of this function g, that is equal to r minus 0, and this value is equal to the range of the function f. Next we have is find the domain and range of the real function fx is equal to x minus 3 over x minus 5. So we are saying for the domain, we are saying that denominator should not be equal to 0. So if we equate the denominator equal to 0, we get the value of x is equal to 5. So we are saying the domain of this function f, domain of the function f, that is equal to r minus 5. That is, this function is defined for all real values except the number 5. To calculate the range of this function, we are trying to find the inverse function. We are equating y is equal to x minus 3 over x minus 5. Now this gives us y into x minus 5y is equal to x minus 3. So this gives us yx minus x is equal to 5y minus 3. So this gives us the value of x is equal to 5y minus 3 over y minus 1. This function is not defined for y minus 1 equal to 0. So we get y is equal to 1. So we are saying this function y is equal to x minus 3 over 5. This is not defined if y is equal to 1. So the domain of this function, it is r minus 1. So this r minus 1, which is domain of this function, is the range of the given function. It is the range of the given function. Now the next question we have, it is find the domain and range of this function. Again, this denominator we equated equal to 0. So we are calculating the domain of this function. So we are getting x square is equal to 1. This gives us x is equal to plus minus 1. So the domain of f we have, that is equal to all real numbers except plus minus 1. We are saying the domain of this function is all real numbers except plus minus 1. Next, to find the range of this function, we are equating this term equal to y. We are writing it is x square plus 1 over x square minus 1. So on cross multiplying, we will get that y x square minus y, that is equal to x square plus 1. This gives us y x square minus x square is equal to y plus 1. So this gives us x square is equal to y plus 1 over y minus 1. So the values of x that we have, that is equal to plus minus square root of y plus 1 over y minus 1. So we can look at this value over here. We are not saying that because this plus minus sign is there, so we cannot write that this is equal to f of or some function g of y. We cannot say it like this because it is plus minus sign over here. So basically we can write it in two forms. We are saying x is equal to some function h1 of y, that is equal to square root of y plus 1 over y minus 1, or h is equal to h2 of y, and we are saying it is equal to, with minus sign, it is y plus 1 over y minus 1. But in both these cases, when we are looking at this value over here, we are saying both these functions, they will not be defined if either the denominator is equal to 0, that is y minus 1 is equal to 0, or y plus 1 over y minus 1 is less than 0 if this value is negative. So this first condition, this will give us if y is equal to 1, and from this second condition we will obtain, from this second condition we are saying that y plus 1 over y minus 1, this should be less than 0. We are saying this term is negative, and this thing is possible if both of these terms have the opposite sign. Both of these terms have the opposite sign means if y plus 1 is greater than 0 and y minus 1 is less than 0. Either this condition is there, that this is positive and this is negative, the overall answer will be negative, or we are saying y plus 1 is less than 0 and y minus 1 is greater than 0. Now look at this first condition over here. If we write this value, we are saying it is y is greater than minus 1 or y is less than 1. We draw the number line over here. It is 0, minus 1 and 1. We are talking about y is greater than minus 1. It means we are talking about all these numbers over here. Next we are talking about y is less than 1. And we are saying y is less than 1, we are talking about these numbers over here. It is and in between these two values, it means we are talking about the intersection. So the intersection of both these answers, it is minus 1 to 1 interval we are talking about. Now when we are talking about this second case, over here, we are saying we are having this number line over here. So what is x plus 1 is greater than 0. X, this is 0, this is minus 1 and this is 1. So we have y is less than minus 1 and y is greater than 1. So we are saying y is less than minus 1 or y is greater than 1. So there is no common point in between these two. I mean this set is equal to 5. This is an empty set. It is or in between both these, or means it is the union. So we are talking about the union of the set minus 1 comma 1 and 5. So the answer we obtain it is minus 1 comma 1. So the final answer we are getting over here, we are saying it is that the value of y cannot be equal to 1. This thing is coming from this condition. When we are saying that the denominator should not be equal to 0, we are talking about this condition over here. So we are getting that y should not be equal to 1. And second, we are saying that the value of x should be between the y, it should belong to minus 1 to 1. So combining these two results, we get that the value of y that we can have, it is between, this is open interval over here, it is open interval on this side, it is minus 1, and closed interval on this side, it is 1. So we are saying the domain of this function, it is minus 1 to 1 with open interval on minus 1 side and closed interval on 1. So this gives us that the range of this function, it is r minus these points. Next we have to calculate the domain of all these 3 points, these 3 functions we are talking about. We have to calculate the domain of all these 3. So we are saying fx is equal to square root of x minus 3. What we have is that this function is defined if this value is x minus 3 is greater than 0. It means x is greater than 3. We are talking about it is defined when x is greater than equal to 0. So it is x is greater than equal to 3. So x belongs to the interval 3 comma infinity. This interval is closed on this side. Next is gx is equal to square root of x 4 minus x square. We have to calculate the values of x for which this is defined. So again we are saying this part 4 minus x square should be greater than equal to 0. So this gives us that 2 minus x into 2 plus x should be greater than equal to 0. So two cases arise over here. We are saying that the product of these two numbers should be positive. So we are saying 2 minus x is greater than 0 and 2 plus x is greater than equal to 0. This is the first condition. Or we are saying both of these 2 minus x is less than equal to 0 and 2 plus x is less than equal to 0. Now if we draw the number line over here, it is 0, it is 2 minus 2 and 2. So when we are saying 2 minus x is greater than equal to 0, it means we are saying x is less than equal to 2, and this thing gives us x is greater than equal to minus 2. So we are saying x is lesser than equal to 2 or x is greater than equal to minus 2. So the common values we have over here corresponding to this, the common values that we have, it is closed interval minus 2 to 2. Similarly, for the next case, we have drawn the line over here, it is 0, minus 2 and 2. From this first part, what we get is that 2 is less than equal to x, or we are saying x is greater than equal to 2. From the second part, we get x is less than equal to minus 2, and it is and in between these two. So we are saying, we are talking about x is greater than equal to 2 and x is less than equal to minus 2. So this set we are talking about, there is no common portion over here. So the intersection of these two, it is 5. Between both these values we have OR over here. So the final answer we will obtain, it is union of these two intervals, it is minus 2 to 2 and 5. So the domain of this function we will obtain, it is equal to minus 2 to 2. Next we have this function hx is equal to 1 over square root of 1 minus x. So this function will be defined. We have two conditions over here. One is that this denominator should not be equal to 0, and this interior portion we are saying this should be greater than 0. So what we get is that 1 minus x, this should be greater than 0. We are having two conditions over here. Because of the square root sign, we are saying 1 minus x should be greater than equal to 0, and because 1 over x is in the denominator, it is in the denominator, we are saying this should not be equal to 0. So combining both these results, should not be equal to 0 and greater than equal to 0, we obtain that 1 minus x should be greater than 0. So this implies us that 1 is greater than x or x is less than 1. So what is x is less than 1? We are talking about that x, the domain of this function, it is minus 1 to infinity. Look at the number line over here. We are saying it is 0, 1. We are talking about x is less than 1. It is open from this side. So we are getting the interval in the form, it is open interval minus infinity to 1. Now the next question we have is, we have to find the domain of the function fx is equal to this. So suppose we are saying this part of the function, it is gx, and this part of the function, it is hx. So the domain of the function g, we are saying domain of the function g, that will be those values of x for which 3 minus x is greater than equal to 0. So this thing gives us that x is less than equal to 3. So the domain of this is minus infinity to 3, and it is closed at the point 3. And when we are talking about the domain of the function h, this is equal to all those x for which x square minus 1, this should be greater than 0. It is important over here we are putting greater than equal to, and over here we are putting greater than, because this portion, this is the denominator, this is in the denominator. So this value, this cannot be equal to 0. So this equality is removed over here, and we are saying it should be greater than 0. So this gives us x minus 1 into x plus 1, this should be greater than 0. So we are getting two cases over here. We are saying the product of two numbers is greater than 0. It means x minus 1 is greater than 0 and x plus 1 is greater than 0. either we have this condition, or we are saying x minus 1 is less than 0 and x plus 1 is less than 0. Now from these conditions, x minus 1 is greater than 0 means we are talking about x is greater than 1 and x is greater than minus 1. From these conditions we are getting x is less than 1 and x is less than minus 1, and we have or in between these two values. So what this thing means, we are talking about it is 0, 1 and minus 1. We are saying x is greater than 1 and x is greater than minus 1. We are talking about these values over here. So the common values we have, it is 1 to infinity, because 1 is not included over here. Now in the second case, if we draw the number line over here, we are saying it is 0, 1 and minus 1. We are talking about the values x is less than 1, x is less than minus 1. So this minus 1 is not included over here, 1 is not included over here. So we are saying the common values we have, it is minus infinity to minus 1, and it is or over here. So the answer we are writing, it is minus 1 or it is minus infinity to minus 1 union 1 to infinity. We are talking about these two values over here, and this is the domain of the function h we have. Now we are talking about the function gx plus hx. So we are talking about the intersection of both these values. We are saying we have, this is the number line over here, this is 0, this is 1, 2, 3, this is minus 1, minus 2 over here. The domain of the function g, it is minus infinity to 3. So we are talking about it is minus infinity to 3. And when we are talking about this function h, we are saying it has elements minus infinity to minus 1. This is minus infinity to minus 1 and then 1 to infinity. This minus 1 and 1, these are not included. So we are saying this region is the common region and this region is the common region. So this is the region minus infinity to minus 1, and in this case the common region we have, it is this portion over here. This 3 is included in the domain of gx. So we are saying the region, the common region we have, it is all the points from 1 to 3 where 3 is included in this interval. Next we have is find the range of the function. We have to calculate the range of the function gx is equal to x square plus 2. So what we have over here, it is gx is equal to x square plus 2. Now when we are talking about the range, it means we are talking about the values gx can attain, and it is given that the domain of this function is x belongs to R. So if we put any value, we are saying the value of x we have, it is in R. So this implies us that the value of x square we have, that will be greater than equal to 0. So the value of x square plus 2 that we can have, it is 0 plus 2 is equal to 2. So what we get is that this value is always greater than equal to 2. So the range of this g, that is equal to, that is the values this function can attain, it can be equal to 0 or any value greater than 0. So we are getting that the range of this function g, that is equal to 2 to infinity with closed interval at 2. That is, this point 2 is included in this interval. In place of interval, we can also use the term ray over here. Next is find the domain and range of the real function fx is equal to square root of x minus 3. So first of all, when we are talking about the domain, we are saying that x minus 3 should be greater than equal to 0. This implies us that x is greater than equal to 3. So the domain of this function will be closed interval 3 to infinity. It is open at infinity. This thing we already know. Next we have to tell the range of this function. So for these values, for x greater than equal to 3, this is the domain we are saying. For x is greater than equal to 3, we are saying x minus 3 is basically greater than equal to 0. So square root of x minus 3 is also greater than equal to 0. It means this function, for the values of x, this function can have values greater than equal to 0. So the range of this function will be closed interval 0 to infinity. Why it is closed? Because it is greater than equal to 0. Next is find the domain of single valued function y is equal to fx given by 10 raised to the power x plus 10 raised to the power y is equal to 10. So this function y is equal to fx is given, and how it is defined? It is 10 raised to the power x plus 10 raised to the power y is equal to 10. So we are writing it is 10 raised to the power y is equal to 10 minus 10 raised to the power x. So the value of y we have, it is equal to log to the base 10 of 10 minus 10 raised to the power x. Now we know that this log function is defined only when this term is greater than 0. So we are saying 10 minus 10 raised to the power x should be greater than 0. For this function to be defined, this should be greater than 0. So what we get is that 10 raised to the power x is less than 10, and this thing implies us x is less than 1. So we are saying what values of x can be substituted over here? It is x is less than 1. So the domain of this function is minus infinity to 1. It is less than over here. So this bracket is this interval, we are saying this 1 is not included in these points. So we are saying the domain of the function fx is x is less than 1, or we are writing x belongs to minus infinity to 1. Next we have is find the domain of fx is equal to, and this function is given to us. Now the first condition we have is that the denominator should not be 0, because this portion is in the denominator part. Second condition we have is that this term, this is in the square root, so we are saying this term should be greater than equal to 0. So combining this result, we are getting that log 1 by 2 x square minus 7x plus 13, this should be greater than 0. Now the next condition we have is that this term which is inside the log, this should be greater than 0, because log is not defined for the negative values, or we are saying for the non-positive values. So we are saying the value of x square minus 7x plus 13 should also be greater than 0. So when we look at this value over here, we are saying this term is greater than 0. The value of the log is greater than 0, and this thing is only possible when the value of x square minus 7x plus 13, this value is less than 1. So this implies us that x minus 3 into x minus 4 should be less than 0. So if we try to solve this value, we are saying we are drawing the number line over here. We are having the roots over here, they are 3 and 4. So we are interested in these points 3 and 4 over here. So we are saying if we substitute any value less than 3, if we substitute any value less than 3, then this, we are talking about two numbers over here. One is x minus 3 and one is x minus 4. First of all, I am talking about the condition less than 3, that is x is less than 3. So what will happen if I substitute the value less than 3? Then this first value will be negative, and this second value, it is also negative. So overall answer we will have, that will be positive. So we are saying we are not interested in these values when we are substituting the value of x less than 3. So this is not this region, this does not contain any of the solution of this portion. Suppose I am substituting the value of x greater than 4. If we substitute the value x greater than 4, then x minus 3 will be positive, x minus 4 will be positive, and overall answer in both these cases this is positive. So it means this region also does not contain the solution. We are saying when x is less than 3, this region does not contain the solution. This region does not contain any x for which this is satisfied. Now if we substitute the value of x between 3 and 4, so what we will get? If we substitute x lying between 3 and 4, you will get this first value. This will be, we are saying x is greater than 3. So this value is positive. This second value is negative. So overall answer is negative. So we are saying that this equation, this inequality, it has a solution 3 is less than x is less than, this is possible when this is 3 is less than x is less than 4. So this is the answer we are getting for this. Second is, we are talking about this function x square minus 7x plus 13. So by completing the whole square, we are writing it is x square minus 7x plus 49 by 4 plus 13 minus 49 by 4 should be greater than 0. So we are saying x minus 7 by 2 square plus 3 by 4 is greater than 0. We are saying this term, it has square over here. So this whole term is always greater than equal to 0. It means this whole value, this is always greater than 0. It means if we substitute any value of x, any real value of x, the answer is always positive. For any real value of x, the answer is always positive. So we are saying this is true for all x belongs to R. So the domain of this function, we are saying that will be intersection of these two, and the intersection of these two sets, that is 3, 4 interval, and this is R. Intersection of these two, it is the interval 3, 4 that we have. So this is our answer, that the domain of fx is equal to open interval 3, 4. The next function that is given to us is fx is equal to 1 over log to the base 10 1 minus x plus square root of x plus 2. Now again there are two functions over here. This is the function say gx and this is the function hx. For the domain of the function hx, we are saying x plus 2 that should be greater than equal to 0, and this is true when x is greater than equal to minus 2. So the interval we are writing it is minus 2 to infinity, and it is closed at minus 2. Now for the domain of this function gx, we are saying gx is equal to 1 over log to the base 10 1 minus x. So we are having two conditions over here. One is that log to the base 10 1 minus x, this should not be equal to 0, and we know that this value is never equal to 0. And second thing we are talking about, that 1 minus x should be greater than 0. 1 minus x means this value inside the log, this should be greater than 0. So we are saying that 1 minus x, from this condition what we are getting is that 1 minus x should not be equal to 1, because we know that log 1 is equal to 0. That means this value should not be equal to 1, and from this condition we are writing x is less than 1. So we are saying x is less than 1. From this we are getting x is not equal to 0. So if we draw the number line over here, this is 0, 1, 2, minus 1, minus 2. From the first condition, we are saying the points we have, these are minus 2 to infinity. We are talking about all these points are there. From the second condition, we are saying x is not equal to 0. From third, we are saying that x is less than 1. X is less than 1. So this is the common region we have with 0 as excluded point. So the interval we obtain, it is minus 2 to 0. It is closed at minus 2, open at 0. Union, this portion we have, it is 0 to 1 and it is closed at this point 1. So this is the domain of the function fx that we will have. The next function we have, it is log to the base 10, log to the base 10 and 1 plus x cube. Now we know that the domain of this function will be, this value should be greater than 0. Next, this value should be greater than 0. Because of this log, this condition is there, and because of this log, this condition is there. So we are saying 1 plus x cube should be greater than 0, and log to the base 10 into 1 plus x cube should be greater than 0. Now 1, from this condition we are getting that x cube should be greater than minus 1. So this implies us that x is greater than minus 1. From the second part, we are saying this term should be greater than 0. So this gives us that 1 plus x cube should be greater than 10 raised to the power 0, because 10 is the base over here. This becomes the exponential over here. So it is 1 plus x cube is equal to 1. So we get x cube is greater than 0. So this gives us x is greater than 0. So we are talking about, this is the number line, this is the point minus 1, this is the point 1. We are saying x is greater than 0. This portion we are talking about. And second we have is x is greater than minus 1. We are saying these are the points for which x is greater than minus 1. This 0 is not included over here. So the final answer we obtain for this, it is 0 to infinity. We are saying this is the common region that we will have. It is 0 to infinity. Next we have is find the domain of fx, where fx is equal to log 10, log 10, log 10, log 10 of x. Now this x should be, we are saying first condition we are getting is that x should be greater than 0. Next we have this log to the base 10x should be greater than 0. Next condition we have, it is log of x should be greater than 0. The next condition we have is, from this, it is log of x. This should be greater than 0. Now we are having these 4 conditions over here. From this condition we are saying x is greater than 0. From this second condition we will get that the value of x we will have, it is greater than 1. From this third condition we are getting that log x should be greater than 1. From this fourth condition we have log of x should be greater than 1. Now this condition gives us the base we have over here, it is 10. So we are saying that x is greater than 10. Now from this condition we are getting, we are talking about, we are getting that log x is greater than 10. and this implies us that x is greater than 10 raised to the power 10. So the common conditions we are getting is, if we draw the number line over here, it is 0. Suppose this is the point 1, this is the point 10, and this is 10 raised to the power 10. We are saying x is greater than 0. So these are the points we are talking about. Next we are saying x is greater than 1. So these are the points we are talking about. Next we are saying x is greater than 10. So these are the points we are talking about. And last we have is x is greater than 10 raised to the power 10. So these are the points we are talking about. So the common points we have over here, these are the common points we are talking about. So the answer we are obtaining in this case, it is 10 raised to the power 10 to infinity. The domain of this function is 10 raised to the power 10 to infinity. Next is find the domain, the definition of this function. So we have two conditions over here. One is that the denominator should not be equal to 0. And from this part we are having that this x plus 3 should be greater than 0. So this thing is mentioned over here that x plus 3 is greater than 0. So this gives us x is greater than minus 3. Second, this denominator should not be 0. So we are saying on factorizing this, we are getting it is x plus 1 into x plus 2 is not equal to 0. So we are getting x is not equal to minus 1 or minus 2. Again, draw the number line over here. It is 0, minus 1, minus 2, minus 3, 1, 2 and 3. We are saying x is greater than minus 3. Minus 3 is not included. Further, minus 1 and minus 2 is to be excluded. So the answer we obtain is that it is minus 3 to infinity minus the element minus 1 and minus 2. 3 is already removed, and these 2 points, these are removed in this way over here. So the domain of this function fx we get, it is equal to minus 3 to infinity minus the points minus 1 and minus 2. Now the next we have is find the domain of fx is equal to square root of cos x of cos of sin x. Now we know that the value of sin x, it lies between minus 1 and 1. And when we are talking about the value of cos of sin x, the values of sin x, they are between minus 1 and 1. And we know that this value is greater than equal to 0 for all x as mod of pi by 2 is greater than 1. We are saying mod of pi by 2 is greater than 1 means if we calculate the value of pi by 2, this is 3.14 by 2. So that is 1 point something. So we are saying that this value is less than minus pi by 2 and this value is less than pi by 2. So we are saying whatever the value of sin x we will obtain. So I am writing y is equal to sin x. Now we are talking about the function cos y where minus pi by 2 is less than y is less than pi by 2. And we know that if the value of y is in this region, then cos y is also positive, or we are saying it is non-negative. So this condition is written over here. So we are saying that cos of sine of x is greater than equal to 0 for all x. So the domain of this function fx is R. That is, this function can take any value R. The x can take any value, not function. It is x can take any value R from R and we will obtain the answer. Next is the function fx is defined in closed interval 0, 1. You have to find the domain of f of tan x. It is given that x belongs to closed interval 0, 1. So what is basically given to us is that we have to find those values of x for which 0 is less than equal to tan x is less than equal to 1. We have to calculate those values of x for which this tan x, the value of this tan x, it lies between 0 and 1, because it is given that the values for which fx is defined, the x they are lying between 0 and 1. So on solving this, we are having tan x is equal to 0. It means the value of x we have there n pi. This is less than equal to tan x is less than equal to n pi plus pi by 4. This thing we know. If we solve this equation, tan x is equal to 0, we will get the answer x is equal to n pi. If we solve the equation tan x is equal to 1, we will get the answer, it is n pi plus pi by 4. So we are getting the domain of the function f of tan x is n pi comma n pi plus pi by 4. Now next we are given this function fx is equal to log of log to the base mod of sin x. Then this value is given to us, it is x square minus 8x plus 25, then minus 3 over log to the base 2 sine of x. We have to find the domain of this function. So first of all, we are looking at this term over here. So we can write this whole term, we are talking about this is equal to log of, it is log of mod of sin x into the value we have over, it is not into, it is x square minus 8x plus 25. I'm looking at this value over here, so we can write this is 3 into log of mod of sin x of 2, and this is equal to log of mod of sin x, it is 2 raised to the power 3, that is equal to 8. So we are saying we are having this value over here, that is log of this minus log of 8. So minus sign is there, so this value will come in the denominator over here. So we are getting it is equal to our 8. So this question becomes, we have to find the domain of fx is equal to log of base is the sin x, and this value over here it is x square minus 8x plus 25 by 8. So our problem, it comes in this form. So now we have the condition over here that this term x square minus 8x plus 25 by 8, this should be greater than 0. Next we are saying log of mod of sin x, x square minus 8x plus 25 by 8, this should be greater than 0. Next thing we have is that this base we are talking over here, this base should not be equal to 0 or 1. So on solving these values, what we will get is, from this condition we are saying that sin x should not be equal to 0 or plus minus 1. From next we are saying that x square minus 8x plus 25, it should be greater than 0. From the next condition we are getting that x square minus 8x plus 25 by 8, this should be less than sin x raised to the power 0. So this first condition, this gives us that x is not equal to n pi or 2n plus 1 pi by 2. Now we are talking about this condition over here, this becomes 1, this 8 goes on this side, so we are left with this x square minus 8x plus 15 should be less than 0. Second we have is x square minus 8x plus 25 should be greater than 0. So if we complete the whole square over here, we are getting it is x square minus 8x plus 4 square minus 4 square plus 25 is greater than 0. So we are getting it is x minus 4 whole square plus 16 is greater than 0. So for this thing we are saying this x belongs to R. Next we are talking about this term over here. So on solving this we will get it is x minus 3 into x minus 5, it is less than 0, and this gives us that x belongs to open interval 3 comma 5. So we have these values of x. We are saying x should not be equal to this, x belongs to R and x belongs to 3 comma 5. So if we draw the number line over here, x belongs to R, this is covered on whole number line. Then we are talking about this is 1, 2, 3, 4, 5. This point it is 0, this is minus 1, this is minus 2. So we are saying x belongs to 3 to 5. We are talking about these points over here. Next we are saying that x is not equal to pi. Pi means it is 3.14. And next we are saying that x should not be equal to, the values we have it is 2n plus 1 pi by 2. So the values that lie in between the value 3 and 5, they are pi and 3 pi by 2. So we are saying this some point pi is there. And when we are talking about 3 pi by 2, so this is equal to 3 into 3.14 divided by 2. So this point we are saying it is something 4 point something over here. So this point we will have it is 3 pi by 2. So we are saying these points are to be excluded. So the interval we have it is 3 to pi, then pi to 3 pi by 2. It is important to note over here that it is open from this side, it is open from this side, and last point we have it is 3 pi by 2 to 5. So the final answer we obtain that x belongs to this interval, and this is not the interval, it is union of the intervals. Now the next question we have, find the domain of y is equal to square root of 1 over mod x minus x. So we are saying that this value should be greater than 0. So we are saying mod x minus x should be greater than 0. It means mod x should be greater than x. And we know that this thing holds if this value of x we have, it is between minus infinity and 0. Now why we are having this value? We know that the definition of mod x we have, it is equal to x when x is greater than equal to 0, and it is minus x when x is less than 0. So we are saying x is always lesser than minus x, and this thing holds only for the case when x is less than 0. We are saying this case, this holds only when x is less than 0. So x is less than 0 means x belongs to the interval minus infinity to 0. So we are saying the domain of y is minus infinity to 0. Next, the function that is given to us is y is equal to cos inverse of 1 minus 2 mod x over 3 plus log of base over here, it is x minus 1 and the number and this x is there. So we know that the value of cos inverse, it means this value we are saying this should lie between minus 1 is less than equal to 1 minus 2 mod x over 3 is less than 1. It is because the domain of cos function, it is minus 1 to 1. Next, from this value we are saying that this x should be greater than 0. This mod of x minus 1, this should be greater than 0. And third condition we are saying this mod of x minus 1 should not be equal to 1. So on solving these values, we are talking about, first we are solving this value over here. We are getting it is minus 3 is less than equal to 1, minus 2 mod x is less than 1. So this gives us minus 4 is less than equal to minus 2 mod x is less than equal to 3. So we get it is 2 is greater than equal to mod x is greater than equal to minus 1. So what values we are getting from this is that mod x is less than equal to 2, and this is the first we are getting, and we are saying that mod x is greater than equal to minus 1. So mod x is lesser than equal to mod x is greater than equal to minus 1. This thing is true for all real x, and when we are talking about this condition, this thing holds for the interval minus 2 to 2 closed interval. So intersection of these two will give us the points minus 2 to 2 closed interval we are saying. Next we have these three conditions over here. First is x is greater than 0. The second condition we have is that mod of x minus 1 is greater than 0, and the third condition we have is mod of x minus 1 is not equal to 0. So if mod of x minus 1 is not equal to 0, we get that x minus 1 is not equal to plus minus 1. So this gives us x is not equal to 0 or 2, because it is x minus 1 is not equal to 1, x minus 1 is not equal to minus 1. So x is not equal to 2 and x is not equal to 0. When we are saying mod of x minus 1 is greater than 0, it means the values we will get from this is that x should not be equal to 1. Only for x is equal to 1. If x is equal to 1, then mod of x minus 1 is equal to 0. Otherwise, for all other values, it is greater than 0. So we are saying the value we are getting from this is x is not equal to 1. From the first, we are getting x is greater than 0. And last, from this, we are getting it is this value we are talking about. So we have three conditions we have obtained, that is x is greater than 0. Second condition we are getting it is x is not equal to 1, and third we are getting x is not equal to 2 and 0. So on combining all these values, if we draw the number line over here, we are saying this is the number 0, this is 1, this is 2, this is minus 1, and this is minus 2. From this condition, we have this region that the values we have it is between minus 1 and minus 2. Next, we are saying x is greater than 0. We are talking about these values. Then we are saying 1 is not included, 0 is not included, and 2 is not included. So the common region we are left with is this is 0 to 1 over here, and this region 1 to 2 we are saying, this region we are saying it is union 1 to 2. So the values of x we have it is interval 0 comma 1 union 1 comma 2. Next we have is find the domain for fx is equal to greatest integer function of sin x, and we know that this x has the domain r. The value of sin x, it lies between minus 1 and 1, and this greatest integer function is has the domain r. So this value, it is defined for every value r. Next we are talking about this cos function over here. We are saying cos is also defined for every value. Next, what is the problem over here? We are saying if this term, that is greatest integer of x minus 1, this will be 0, then this part we are talking about pi over greatest integer of x minus 1 will not be defined. So we are saying that this should not be equal to 0. So we are interested in the points x such that this value is equal to 0. So we are saying these values are when this x minus 1 will lie between 0 and 1. So this gives us that x is between 1 and 2 with 1 included and 2 not included. So what we get is, for this first part, the domain we have it is R. For this cos, we are saying this portion, we are saying the domain it is R. Because of this term, the domain we have it is 1 to 2. So what we get is that for all real numbers except for the numbers between 1 to 2, this function fx is defined. So the domain of fx is R minus interval 1 to 2, this semi open interval 1 to 2. Next we have this function fx is given to us. This is the function given to us, and it is given that these brackets that are given over here, they represent the greatest integer function, and we have to find the domain of this function. So to calculate the domain, we are having two conditions over here, that this denominator should not be equal to 0, and this part over here in the logarithm, this should be greater than 0. So this is mentioned over here that this value should be greater than 0, and this denominator part should not be equal to 0. So when we solve this denominator part, we will get that the values of x should not be 1 and minus 2. Now we come to this numerator part. It is 5 minus greatest integer of x minus 1 minus x square is greater than 0. So this thing gives us that x square, we are talking about the greatest integer of x square plus greatest integer of x minus 6 should be less than 0. We are saying when we are writing, we have taken the negative sign common from this, then this term will become positive, this will become positive, this will become negative. What is greatest integer of x minus 1? That will be equal to greatest integer of x minus 1. So this minus 1 and minus 5, this will become minus 6. This becomes a quadratic equation in this function. So you are writing it is greatest integer of x plus 3 into greatest integer of x minus 2. This should be less than 0, and this implies us that minus 3 is less than greatest integer of x is less than 2, and this thing implies us, we are saying the, if we draw the number line, it is minus 3 over here, it is 2 over here. We are saying the greatest integer value, it lies between minus 3 and 2. Minus 3 and 2 means that it should be greater than minus 3. It means its value can be minus 2, minus 1, 0, 1. Its values can be minus 2, minus 1, 0, and 1. So we are writing this in the interval form, like x belongs to this. We are saying the answer for these values, it can be minus 2, minus 1, 0, and 1. So if the value lies between minus 1 and 2, the answer is minus 2. If the value lies between 0 and 2, the answer is minus 1. If the value lies between 1 and 0, the answer is 0. And if the value lies between 1 and 2, the answer will be 1. So we are saying the final answer we will obtain for this, it is this, that minus 2 is less than equal to x is less than 2. So the domain of this function we get, it is, further we have, now we are having two conditions. We are saying that x belongs to minus 2 comma 2 and x is not equal to 1 and minus 2. So if we remove these 2 points, we are saying this is the number line, this is minus 2, this is 2. 2 is already removed. This is the point 0, this is the point 1. 1 is removed, minus 2 is removed. So what we are left with is, we are left with the interval minus 2 to 1. this portion we are talking about, it is minus 2 to 1, and second we are left with is 1 to 2. So the domain of this function is minus 2 to 1 union 1 to 2. Next is the function fx is equal to 1 over square root of greatest integer of x minus x. And we know that this function will be defined if greatest integer of x minus x is greater than 0. This implies as greatest integer of x should be greater than x. Now we know that x is equal to greatest integer of x plus this, where this value, it lies between 0 and 1. So what we get is that x is this greatest integer we are saying, or we are saying x is, this greatest integer of x is always less than x, less than equal to x. But what condition we want over here? We want those values of x, we want those values of x for which greatest integer of x is greater than 0. But this thing holds always, this is always true. So we are saying this set is equal to 5. So the domain of this function is 5, that there is no such function. Next is if the domain of the function y is equal to fx is this closed interval minus 3 to 2. Find the domain of the function gx is equal to, the function gx is f of mod of greatest integer of x, and the domain of the function this is minus 3 to 2, that is x belongs to minus 3 to 2. So what we get is that for this function g to be defined, we are saying this value we have, this should lie between minus 3 to 2. So what we get is that minus 3 is less than equal to mod of greatest integer of x is less than equal to 2. It is mod over here, and we know that the mod function, it is always greater than 0. So we are writing 0 is less than equal to greatest integer of, we are saying it is mod of greatest integer of x is less than equal to 2. We can write this as it is minus 3 is less than equal to mod of x is less than 0, and this condition we are saying this value mod of the number we have, it is not and over here, it is or over here. So we are saying this set basically it is 5. There is no number x for which mod of x is less than 0. This is 5. So, and the union of 5 with any set, that will give us the same set. So we are left with this term over here. So this gives us mod of x, greatest integer of x is less than equal to 2. So we get minus 2 is less than equal to greatest integer of x is less than equal to 2. Now draw the number line over here. We are saying this is 0, minus 1, minus 2, 1 and 2. We are having all the values between minus 1 and 2. So we are saying the greatest integer values that this x can have. We are interested in all those x for which greatest integer of x is minus 2, minus 1, 0, 1 and 2. So the value of minus 2 will be for all these points. The value of minus 1 will be for all these points. 0 will be for all these points. 1 will be for all these points. And 2 will be the points 2 to 3. So we are saying this set is equal to minus 2 to 3. This is open at 3 because at 3 the answer will be 3. And for any x lesser than 3, the greatest integer of x will be equal to 2. We are saying when the values of between 2 and 3, the answer will be 2. So the domain of this function g, we are saying it is minus 2 to 3. Next we have is find the domain of the function. The function given to us is fx is equal to 1 over, it is greatest integer of mod of x minus 1 plus greatest integer of 7 minus x minus 6, where this function it is the greatest integer function. Now we are saying this function will be defined. The condition we have is that this term should not be equal to 0. It means that the greatest integer of, so if we look at these terms over here, we are drawing the number line. We are having the points of 1 and 7 we are basically checking. It is 0, 1 and some point 7 is there. We are saying if the value of x it is less than 1. We are talking about all the points for which the value of x is less than 1. Now in this region, what is the value of mod of x minus 1? We are saying when the value of x is lesser than 1, suppose we are substituting it is equal to 0, this value it is negative, so this answer will be equal to minus of x minus 1, so that is equal to 1 minus x. So we are talking about the case when x is less than equal to 1. We are saying this term will become 1 minus x, and this term 7 minus x, and we are talking about the term mod of 7 minus x. We are saying the value is less than 1, so this is greater than 0, so the mod will be removed and we are left with this 7 minus x, and this should not be equal to 6. Now the second we are talking about, it is when the value of x we have it is between 1 and 7. So when the value of x is between 1 and 7, again this mod of x minus 1 we are talking about, this is the value of 7 minus x we are talking about. So mod of x minus 1 now it will be positive. So it will be positive means now this value will be equal to x minus 1. So we are saying it is x minus 1 plus 7 minus x should not be equal to 6, and these are the values when 1 is less than equal to x is less than equal to 7. And third condition we have, it is when x is greater than equal to 7. We are talking about these values over here. So in this case we will have the first value will be positive, so the answer we will obtain it is x minus 1 plus x minus 7, and this should not be equal to 6. So these are the three values we are talking about. These are the three values we are saying that we have because of this mod function. This mod function we are talking about, we have these values. When we are looking to adjust this mod, we will get these three equations. So now from the first part we are saying, this is the first equation we are talking about. We are saying greatest integer of x minus 1 plus greatest integer of x 7 minus x. This is the case. This is not the first part, this is the second equation we are talking about. So when we are writing it is greatest integer of x minus 1, we know that is equal to greatest integer of x minus 1, and greatest integer of 7 minus x, that is equal to 7 plus greatest integer of minus x. So we are writing the final answer we are getting. This implies us that greatest integer of x plus greatest integer of minus x, it is not equal to 0. So what we get is that x is not an integer. Now the values of x in this case it is between 1 to 7. and we are saying x is not an integer. So the answer we are getting is that x is not equal to 1, 2, 3, 4, 5, 6 and 7. Similarly, in the second part, what we get is that it is 1 plus greatest integer of x plus 7 plus greatest integer of minus x. It is not equal to minus 6. On solving this, we will get that greatest integer of minus x is not equal to 1. So this thing gives us that x belongs to 0 and 1. We are saying that the greatest integer of minus x, that will be equal to minus 1. This thing implies us that x belongs to 0 comma 1. So if we are saying that it is not equal to this, so we are saying this does not belong to 0 comma 1. Similarly, for the third case we have solved over here, you can look at this solution and try at your own. We are saying it is greatest integer of x minus 1 plus greatest integer of x minus 7 is not equal to 6. Separating these terms, we will get it is greatest integer of x minus 1 plus greatest integer of x minus 7. It is not equal to 6. So we will get greatest integer of x is not equal to 7. So x does not belong to 7 comma 8. And this interval is closed from this side and open from this side. So the domain of the function f we have, it is r minus these are the intervals that we have subtracted. This is the interval 0 comma 1, it is subtracted. Then the interval 7 comma 8 is removed, and then these are the numbers which are to be removed. That is, these are the integers we are talking about. 1, 2, 3, 4, 5, 6, 7. These integers are also to be removed. Next we have is find the domain of the function fx, and fx is this function given to us. So again, this function is in two parts. We are saying, suppose this function we have it is hx, and this function we are saying it is gx. Now to calculate the domain of this gx, we are saying this should not be equal to 0. So this value is not equal to 0. This implies that greatest integer of x is not equal to minus 5. So this implies us that x does not belong to minus 5 comma minus 4. Why? If we draw the number line over here, we are saying this is 0. This number we are saying it is minus 5. We are saying that the greatest integer should not be equal to minus 5. And the value of minus 5 will be there for all the numbers between minus 5 and minus 4. So we are saying if x is not equal to, and x does not belong to this interval, then greatest integer of x is not equal to minus 5. So this is the domain of the function gx we are talking about. Next one, we are talking about this hx. We are having the first condition that x square plus 10x plus 25, it should be 0. And from this what we get is that x plus 5 whole square is greater than 0. It is greater than 0 over here. It is important to note it is greater than 0 over here. And this thing will not hold only if x is not equal to minus 5. This thing will not hold x is not equal to minus 5. So we are saying this is the first part we are getting, that x should not be equal to minus 5. Next, the second condition we will have is that log of 1 by 3 x square plus 10x plus 25, this should be greater than 0. So what we get is that x square plus 10x plus 25 should be less than 1. We are having the condition, we are saying if it is log a b is equal to c, then what this thing actually means is that a raised to the power c is equal to b. So when we compare it with this equation over here, we suppose it is equality sign over here. So we have 1 by 3 raised to the power 0. This should be equal to x square plus 10x plus 25. and this value is equal to 1. Now same thing we have over here, it is greater than sign. So what we get is this sign we have, it is actually greater than over here. So this equation will come in this form. So we get x square plus 10x plus 24 equal to 0. And on solving this quadratic equation, this is greater than 0. And on solving this quadratic equation by using the middle term, we will get x plus 6 into x plus 4 is less than 0. So this gives us x belongs to minus 6 comma minus 4. So the final answer we obtain, we draw the number line over here. We are saying we are having the number 0. Somewhere over here it is minus 4, minus 5, minus 6. So first value we are saying that x is not equal to minus 5. Second we are saying x belongs to minus 6 to minus 4. X belongs to this region over here. And next we have is x does not belong to minus 5 to minus 4. That this region is to be excluded. So what we are left with is this portion. It is minus 6 to minus 5. We are saying we are left with this portion over here. It is from minus 6 to minus 5, and this interval it is open from both sides. Next is find the range of the function. It is y is equal to x minus greatest integer of x over 1 minus greatest integer of x plus x. So if we look at these values over here, we are saying the value of x we have, it is greatest integer of x plus the fractional part of x. So this thing gives us that x minus greatest integer of x, that is equal to fractional part of x. So this equation becomes fractional part of x over, this is x minus greatest integer of x. So it is 1 plus fractional part of x. So the function we get, it is y is equal to x over 1 plus fractional part of x. So it is y plus y into fractional part of x, that is equal to this. So we get y is equal to fractional part of x into 1 minus y. So this implies fractional part of x is equal to y over 1 minus y. Now we know that the fractional part of x, it lies between 0 and 1. So we get that 0 is less than equal to y over 1 minus y is less than 1. And this gives us the values of y. From this we can get the values of y. So on solving this value, we will get that 0 is less than equal to y is less than 1 by 2. So what we get is that y belongs to closed interval 0 comma 1 by 2. Next we have to find the range of the function fx is equal to e raised to the power x over 1 plus greatest integer of x when x is greater than equal to 0. So it is given that x is greater than equal to 0. So it means the domain of this function, it is all non-negative real numbers. Now we have e raised to the power x. It is greater than equal to 1 because x is greater than equal to 0. And when we are talking about the greatest integer function of x, it is also greater than equal to 0. And this implies 1 plus greatest integer of x is greater than equal to 1. So it is clear that the minimum value of this function that we can have, it is going to be 1. And as this function, as the values of x we go on increasing, we will get the next and next positive values. So we are saying that there is no maximum value that we can obtain. No maximum value means that the range of this function, that will be the interval 1 to infinity. Now the next question we have is find the domain of this function. So to calculate the domain, we are saying that this denominator, this portion over here, this should be greater than 0 because it is in the denominator. So it should not be 0, and it is in the square root, so it should be positive, greater than equal to 0. So we are getting it is 4x minus mod of x square minus 10x plus 9. This term should be greater than 0. So we get it is x square minus 10x plus 9 mod. This should be less than 4x. So what we get from this is that minus 4x is less than x square minus 10x plus 9 is less than 4x. Now if we look at these two conditions over here, we are getting it is x square minus 10x plus 9 is greater than minus 4x. So it is x square minus 6x plus 9 is greater than 0. If we look at these two conditions over here, we get x square minus 10x plus 9 is less than 4x. So we get x square minus 14x plus 9 is less than 0. So on solving these equations, we will get it is x square minus 3x plus 9 is greater than 0. So it is x minus 3. We are writing, we have taken x common, minus 3 into x minus 3, that is equal to 0. So we get x minus 3 square should be greater than 0. So we are saying, getting the value that x is not equal to 3. Now from this second equation, we are having the values from this equation. If we complete the square, we are having x square minus 14x plus 7 square minus 7 square plus 9 is less than 0. So we get x minus 7 square should be less than 40. So the value for this we will get, it is mod of x minus 7. We are taking the square root, so it is mod of x minus 7 should be less than plus minus square root of, or we are saying it should be less than 40, square root of 40. So what this gives us, that minus root 40 is less than x minus 7 is less than plus root 40. So what we get is that 7 minus square root 40 is less than x is less than 7 plus square root of 40. So the values of x we get from this, it is 7 minus square root of 40 to 7 plus square root of 40. We have to remove the value 3 from it, which we are getting from this answer. So the final answer for the domain we are obtaining, it is in this form. Next we have is find the domain and range of the function. It is y is equal to log to the base e 3x square minus 4x plus 5. So to find the domain, we are saying this value 3x square minus 4x plus 5, this should be greater than 0. So to solve this equation, we are completing the whole square. Suppose we are taking 3 common. We are left with is x square minus 4 by 3x plus 5 by 3. This should be greater than 0. It means this term should be greater than 0. So we are writing x square minus 4 by 3x plus 2 by 3 square minus 2 by 3 square plus 5 by 3. This should be greater than 0. So we are writing it is x minus 2 by 3 square. Then this term we are writing, it is, we are multiplying and dividing with 3. So we are getting it is 4 by 9 plus 15 by 9. This should be greater than 0. So the answer we obtain over here, it is x minus 2 by 3 square plus 11 by 9 is greater than 0, and this holds for all values of x belongs to R. So we are saying the domain of this function is x belongs to R. Now we have to calculate the range of this function. So to calculate the range, we are writing e raised to the power y. From this equation we are writing it is e raised to the power y is equal to 3x square minus 4x plus 5. Now this gives us 3x square minus 4x plus 5 minus e raised to the power y is equal to 0. So if we solve this equation, the discriminant we will have that is equal to minus 4 square minus 4 into 3 into 5 minus e raised to the power y, and this should be greater than equal to 0, and this gives us 12 e raised to the power y is greater than equal to 44. So we get e raised to the power y is greater than equal to 11 by 3, and this gives us the value of y is greater than equal to log of 11 by 3. This value is greater than equal to y is this. So this is the range set we have obtained, that it is the interval closed from this side, it is log of 11 by 3 to the point infinity. Next we have to calculate the range of this function. So to calculate the range, we are first calculating the domain of this function, so that we should know that what values x can obtain, and corresponding to that we will calculate the values of the range. So for this function to exist, we are saying the value of this whole term, this should be greater than 0. So we are getting that log to the base 1 by 2 x square plus 4x plus 4 should be greater than 0. So this thing gives us that x square plus 4x plus 4 is less than 1. Again we are using log a b c, that is equal to a to the power c equal to b. So this thing further implies us that x square plus 4x plus 3 is less than 0. So this gives us x plus 1 into x plus 3 is less than 0, and this gives us minus 3 is less than x is less than minus 1. We are getting minus 3 is less than x is less than minus 1. Next, this term we are having, this term is again x square plus 4x plus 4. This is also to be greater than 0, and we are saying this is the value x plus 2 whole square is greater than 0, and this thing happens only, this thing implies that x is not equal to 2, minus 2. For x, except for value minus 2, all real numbers they will satisfy this equation. So what we obtain is, these are the numbers we are talking about: minus 3, minus 2, minus 1, 0, 1. So from this case we are getting the interval over here, it is minus 3 to minus 1. Minus 3 is excluded, minus 1 is excluded. From this term we are saying minus 2 is to be excluded. So the regions we are getting, it is minus 3 to minus 2 open interval, then minus 2 to minus 1 open interval. So this is the domain of this function. Next, when we have to calculate the range of this function from this value, when we are talking about the domain, we have calculated that the answer for this region, that is log of 1 by 2 x square plus 4x plus 4. This value is always greater than 0 for all values of x belonging to domain of the function. Now when we apply the log to this function again, we will get that the log to the base 3 to this whole function we are talking about, its value should lie between minus infinity to infinity. So we get that the range we have for this function, it is R, that is set of all real numbers. Next we have is if x, y and z are reals such that x plus y plus z that is equal to 4, x square plus y square plus z square is equal to 6. Find the values to which x belongs to. So we are having these two equations. It is x square plus y square plus z square is equal to 6. And second we are saying z is equal to 4 minus x minus y. And if we substitute this value over here, we will get it is x square plus y square plus 4 minus x minus y whole square is equal to 6. On solving this, we will get it is y square plus x minus 4y plus x square minus 4x plus 5 is equal to 0. So this is the equation we are getting on solving, on substituting this z over here. Our equation transforms to this form. On opening this whole square, we are writing the equation in terms of y. Now if we calculate the discriminant for this equation, we are saying discriminant is equal to b square minus 4ac. And for this equation to have a solution, this discriminant should be greater than equal to 0. And on solving this value, this is the discriminant greater than equal to 0. On solving this value, we are getting the answer as it is 3x square minus 8x plus 4 is less than equal to 0. This thing implies us x minus 2 into 3x minus 2 is less than equal to 0. This thing implies us this value. And this implies us x belongs to closed interval 2 by 3 to 2. And this is what we have to calculate. We have to find the values of x for which we have these two conditions, these are satisfied. Now the next question we have is find the range of the function sine mod of sine inverse of mod of sine x minus cos inverse of mod of cos x. Now we know that mod of sine inverse of sine x, that is equal to cos inverse of cos x mod for all x belongs to the domain, elements of the domain of this function. So this, the value of this term over here, this will be equal to 0. So we are saying basically the function fx that is given to be equal to 0. It is a constant function. So the range of this function, the range of fx will be equal to singleton set 0.